Good day, everyone. Today I am going to discuss to you all about the derivative. So here we have our definition for derivative taken from the book of Leithold, which is entitled The Calculus with Analytic Geometry. So now back to our definition. It's given the derivative of the function f is that function denoted by f such that the value at a number x in the domain of f is given by f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0 if the limit exists. So now from this formula, we also have our formula number 2, which was from this formula, of course. Now if x sub 1 is a particular number in the domain of f, then f prime of x sub 1 is equal to the limit of f of x sub 1 plus delta x minus f of x sub 1 all over delta x as delta x approaches to 0 if the limit exists. From this formula, we also have our formula number 3. The following is a formula for f of x sub 1. Now, for the formula number 3, f prime of x sub 1 is equal to the limit of f of x rather minus f of x sub 1 all over x minus x sub 1 as x approaches to x sub 1 if the limit exists. We have here our different notations for derivatives. We have here, this is f prime of x, y prime, dy over dx, or d of f of x all over dx. So we can use any of this notation depending on what is given or how is the expression is given. So now for our examples to come, we are going to use all of this formula, the formula number 1, the number 2, and the number 3. We are now here in our example number 1, which is f of x is equal to x squared plus 7. So this will be our algebraic expression, and this will be the expression that we are going to differentiate using our formula number 1, which is f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0 if the limit exists. Okay, now the first thing that we need to do is to have the derivative notation, which is f prime of x, since our algebraic expression is given as f of x. So, of course, we are going to use f prime of x. So, if it is y equals x squared plus 7, then it would be y prime as its notation. Okay, moving forward, that's f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0. Now, the next thing that we need to do is to use this expression as our basis. And then since we see here that it's x squared, then x plus delta x will be substituted into it. So now it becomes x plus delta x squared. And that, of course, we are not going to forget the 7. So that's plus 7 minus the quantity of x squared plus 7. And then now the next thing that we need to do as for this case is to, of course, expound x plus delta x squared. And that is equal to x squared, since the first that we need to do is to square the first term, and then again, and then plus, multiply these two terms here times 2, and that's 2x delta x rather, and then plus the square of the second term, which is delta x squared, and that is equal to delta x squared plus 7. And then here, as for the minus sign, what we just did is to distribute it with the two terms here, as it is enclosed with a parenthesis. So negative x squared, and that's negative 7. So now it becomes x squared plus 2x delta x plus delta x squared plus 7 minus x squared minus 7 all over delta x. So now, since we have just expounded it using our operations, what we need to do now is to simplify it. So since we see plus 7 minus 7, then that is 0, so it will be cancelled. And then x squared plus x squared, that is 0, so it will be cancelled. So the remaining terms are 2x delta x plus delta x squared all over delta x. And after that, since we have seen a common factor between two terms, so of course, let us going to extract it using its factor, which is the delta x. So 2x delta x factored by delta x, that is 2x, and then delta x squared factored by delta x, that is delta x. Then all over delta x. So since we see something to be cancelled here, and that's delta x and delta x, so canceling them, that gives us 2x plus delta x. Since 2x plus delta x is 0, then 2x plus 0 is equal to 0 is equal to 2x rather. So our or the derivative of x squared plus 7 is 2x using our formula number 1. So that this is the whole process of getting the derivative of this expression, which is x squared plus 7, and that is equal to 2x. So moving on, we have our example number 2. Find the derivative of f at 2 in three ways. Applying formula 2 in the first case, applying formula 3 in the second case, and substitute 2 for x in the derivative. So now let us going to uh, apply formula number 2 for our A. So by the way, the formula our formula number 2 is f prime of x sub 1 is equal to the limit of f of x sub 1 plus delta x minus f of x sub 1 all over delta x as delta x approaches to 0 if the limit exists. So our f of x sub 1 is 3. So f of prime of 3 is equal to the limit of f of 3 plus delta x minus f of 3 all over delta x as delta x approaches to 0. So, but of course, let us not going to forget our expression earlier, which is x squared plus 7. We are going to use it still in this case. What we just did is replacing the x with 3. So there, uh, x becomes 3. So the next thing that we need to do is to square x3 plus delta x, or to expound this. And that gives us 9 plus 6 delta x plus delta x squared plus 7 minus 9 minus 7 here. So 3 squared, that's 9 plus 7. And since there is minus sign here and we have distributed it, so it gives us negative 9 and negative 7. To read it, it is 9 plus 6 delta x plus delta x squared plus 7 minus 9 minus 7 all over delta x. So, since we have noticed plus 7 and minus 7, that is 0, so it will be cancelled. And negative 9 and 9, so that is 0. So the remaining ones or the remaining terms are 6 delta x plus delta x squared all over delta x. Again, since we see something to factor from this expression, so that it is going to be factored, of course. So the factor of these two terms is delta x. So 6 delta x factored by delta x, that gives us 6. And then delta x squared factored by delta x, that gives us delta x. All over delta x. So since delta x and delta x over can be cancelled, so it gives us 6 plus delta x. And since delta x is 0, then 6 plus 0 is equal to 6. So, therefore, applying formula number 2, having f of x sub 1 is 3, that gives us 6 as our answer. So, moving forward with applying formula number 3. Our formula number 3 is f of x f prime of x sub 1 rather is equal to the limit of f of x minus f of x sub 1 all over x minus x sub 1 as x approaches to x sub 1. So by the way, our x sub 1 is 3. So substituting our x sub 1, that is 3. So f of prime of 3 is equal to the limit of f of x minus f of 3 all over x minus 3 as x approaches to 3. So since our f of x is x squared plus 7 earlier, so it will be written as it is minus replacing the x with 3. The quantity of 3 squared plus 7 all over x minus 3. And then focusing on this here, x squared plus 7 minus 16, it's because 3 squared plus 9, that is 16. And then with a minus sign here, so of course it becomes negative 16. So x squared plus 7 minus 16 all over x minus 3. And then using operation, which is 7 minus 16, that is negative 9. So it becomes x squared minus 9 all over x minus 3. And then factoring x squared minus 9, since it can be factored, it gives us x, the quantity of x plus 3 times the quantity of x minus 3 all over x minus 3. So getting something to cancel, it would be x minus 3 all over x minus 3. So that gives us x plus 3. So since x approaches to 3, we are going to substitute x as 3. So 3 plus 3 is equal to 6. So it gives us the same answer using the different formula. So therefore, our answers are correct since it confirms from both formulas. And then for C, let us going to substitute 2 for x in the derivative. No, it's substituting 3 for x in the derivative. I forgot our x sub 1 here is 3. So since now we are going to substitute 3 here, f of x is equal to x squared plus 7. From earlier, we have just come up with 2x using all the formulas. So f prime of x, or the derivative of x squared plus 7, that's 2x. And then substituting 3, it gives us 6. So therefore, our answers are correct since it confirms from the three formulas. So therefore, applying these three formulas help us in getting the derivative of an algebraic expression. So since it confirms that the three formula gets the same answer, then our answer is correct. By the way, substitute 3 rather here. I forgot that it's 3. To move forward, we are going to tackle about the basic differentiation formulas of algebraic expressions. So we will be getting the derivative of different algebraic expressions. So the first one here is, by the way, these formulas are coming from the book of Leithold, or entitled The Calculus with Analytic Geometry. So again, back with our formula, the derivative of a constant. So the formula states that the derivative of c, or the derivative of a constant, is equal to 0. So that simply means that any derivative of a constant is always 0. For example, derivative of 9 equals 0, since again the formula states that derivative of a constant is 0. Then for our example here, that is 0. So any derivative of a constant, that is equal to 0. So next is the power rule. Given the formula, the derivative of x to the n, or the derivative of the power n with the base of x, is equal to n times x to the n minus 1. So it will be simply bringing down the power to be multiplied with the base. And then as for the exponent of the algebraic expression, it will be subtracted by 1. So we have here as an example, f of x is equal to x to the fifth. That's our algebraic expression to be differentiated. So f prime of x, as the notation, is equal to 5x to the fourth. So why it becomes 5x to the fourth? It's simply because we have just followed this formula, which is to bring down the 5 to be multiplied with the base x, though it becomes 5x. And then the fifth as its power is subtracted by 1. So 5 minus 1, that is 4. So the derivative of x to the fifth is 5x to the fourth. So moving on with the constant multiple rule, this will be about getting the derivative of the multiple, or the multiplication of the constant with a function. So that is equal to the constant, or the c, times the derivative of the function to be multiplied with a constant, or the derivative of f of x. So that is equal to, as our example here, given the 3 as the constant and x to the fourth, but as for our as for our function. So f prime of x is equal to 3 as the constant, since we just copied the constant here, times 4x cubed as the derivative of x to the fourth from here. So simply multiplying them together, that gives us 12x to the third. So as simple as that. Moving on, we are now with the formula of getting the derivative of c times x to the n. So the states in the formula, the derivative of c times x to the n is equal to c n times x to the n minus 1. Example here, given the algebraic expression 2x to the 6, it will be simply applying the formula here, which is c as the constant. So we have 2 there, and then getting the derivative of this one, we have just simply brought down the 6 from the power, and then x to the power of 6 minus 1, that is 5. So multiplying them together, 2 times 6 to the fifth, that is 12x to the fifth. So now its leading coefficient becomes 12, applying this formula. Now, to move forward, we are going to discuss about the sum rule. Given the formula, the derivative of f of x plus g of x is equal to the addition of simply getting the derivative of the both functions. So applying them together, based on our example, f of x is equal to x cubed plus x squared. So since it states in the formula that we are going to get first the prime or the derivative of the both function, then of course we are going to get the derivative of these two functions. So x cubed, applying the formula earlier, so bringing down 3 multiplied by the base, so that is 3x x, and then the power, which is 3 minus 1, that becomes 2. So the derivative of the f of x is 3x squared. And then, of course, on the other hand, the derivative of x squared, bringing down 2, multiplied with the base, that's 2x. And then 2 as the power minus 1, that is 2x. So our answer for this is 3x squared plus 2x. So since it cannot be added because they don't have the same variables, then the answer remains 3x squared plus 2x. So we are now in our product rule in differentiation. So in terms of getting the product of differentiation, we have three formulas here. We have the derivative of f of x times g of x is equal to f of x times the derivative of g of x plus g of x times getting now the derivative of f of x. And then we also have here d of x times uv is equal to u derivative of v plus times the derivative of u, or simply written as d times the quantity of uv is equal to u dv plus v du. So in terms of seeing dv, that means getting the derivative of the v, and for du, it means getting the derivative of u. So since I found it convenient to use the third formula, since it is easy to memorize, then we are going to apply it with our example. So given here, find the derivative of f if f of x is equal to 4x minus 5 times 3x plus 5. So this involves multiplication of two functions. So this will be our u and this will be our v from here. So the derivative of uv is given by u dv plus v du. So of course, copying the u, which is 4x minus 5, and then the derivative of v, 3x plus 5, that is 3, plus copying the v, which is 3x plus 5 from here, and then times the derivative of u, which is 4. So it is 4 because the derivative of 5, that's 0, and then the derivative of 4x is 4. So now we can apply our operation, first multiplying this one here. So 4x minus 5, that is 12x minus 15. And then multiplying 3x plus 5 by 4, that's 12x rather plus 20. So applying operations, we have arrived with an answer of 24x plus 5. So therefore, the derivative of the function f of x equals 4x minus 5 times 3x plus 5 is 24x plus 5. We have just simply applied this formula here. So any formulas that is convenient for you, then you can use it. Another formula here. So another example, find dy over dx if y is equal to the quantity of 2x squared plus 7 times the quantity of 3x plus 4. So of course, this will be our u, and this second here is our v. So dy over dx as our notation, since the expression is given as y, so it is expressed as dy over dx, is equal to, from the formula, it gives us u dv plus v du. So our u is 2x squared plus 7, so we will just simply copy it. And then the dv, which is the derivative of v, which is 3x plus 4, that's 3, plus v du, v du. Since our v is 3x plus 4, then we will just simply copy it, times 4x, since the derivative of 2x squared plus 7 is 4x. So simply multiplying this here. So 2x squared plus 7 times 3, that gives us 6x squared plus 21 rather, plus multiplying this one here. So 3x plus 4 times 4x, it gives us 12x squared plus 16x. So summing it all together by its common, or summing it all together according to its variable, so we see that 6x squared plus 12x squared can be added. So it gives us 18x squared rather. And of course, 16x, since it doesn't have someone that they can be added with. So it remains a 16 plus x, and 21 there. Since we don't find any other constant from here, so we will just copy 21. So the answer for the derivative of y is equal to 2x squared plus 7 times 3x plus 4 is 18x squared plus 16x plus 21. So that is how simply we get the derivative of the function 2x squared plus 7 times 3x plus 4 by applying the product rule in differentiation. Okay, so now we are now in the quotient rule in differentiation. So we have here three different formulas. The first one is the derivative of f of x over g of x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. So we have also here other formula, d of x, or the derivative of u over v is equal to v times the derivative of u minus u times the derivative of v all over v squared. And then also here, it's just the same thing from here. It is given by d u over v is equal to v du minus u dv all over v squared. So applying this formula here, from in our example, find the derivative of f of x equals x squared plus 1 all over 2x squared plus 4x plus 8. So this will be our u, and this will be our v. So we are going to simply apply this formula. v du minus u dv. So since this is our v, then we have just copied it here. And then the derivative of u is 2x from x squared plus 1 minus u dv. So since our u there is x squared plus 1, then we have just simply copied x squared plus 1. And then the derivative of our v, which is 2x squared plus 4x plus 8, is 4x plus 4. Now, all over rather 2x squared plus 4x plus 8, since our v squared is our v, from our v, which is 2x squared plus 4x plus 8. So moving forward, we are going to simply multiply these terms here and here. So 2x squared plus 4x plus 8 times 2x, that gives us 4x cubed plus 8x squared plus 16x. And then from here as well, we are simply multiplying them together according to the symbol here. So negative x squared times 4x, that's 4x cubed. And then negative x squared with a 4, that's why it gives us negative 4x cubed. And then negative 1 times 4x, that's negative 4x. And then negative 1 times 4, that gives us negative 4x minus 4. And then I have just simply added them all together. And by simply multiplying these terms here, we have obtained this negative 4x cubed minus 4x squared minus 4x minus 4, all over 2x squared plus 4x plus 8. 8 to the second. And since now we can apply operations here, we have found out that negative 4x cubed and 4x cubed can be cancelled, so that is 0. So that is cancelled out, of course. And then we have also found that 8x squared and negative 4x squared can be put up together. So 8x squared minus 4x squared, that is 4x squared. And then 16x and negative 4x, that's 12x. And then we will just copy here negative 4 since we don't find any other constant na atong ma-apply with the constant here. So combining them together by their operations, we have obtained 4x squared plus 12x minus 4, all over 2x squared plus 4x plus 8 squared, since we are not going to forget our v squared. So I just didn't move it here because it will just be expounded more, and then it doesn't have any common from the numerator. So since we have found a common factor from this expression, which is 4, then now we can express this answer as 4 times the quantity of x squared plus 3x minus 1 all over 2x squared plus 4x plus 8 squared. So that is our answer for the derivative of the function x squared plus 1 all over 2x squared plus 4x plus 8. Another example here, solve for d over dx, derivative of 7 minus x all over 2 plus x. So applying the formula, d over dx times u over v, that is equal to v du minus u dv over v squared. So this will be our u and this will be our v. So the next up, we have simply copied the 2 plus x as our v and negative 1 as the derivative of the u, which is 7 minus x. U is 7 minus x, therefore its derivative is negative 1. And on the other side here, copy the operation minus, and then copy the u, which is 7 minus x, and then the derivative of v, which is 1, all over 2 plus x squared. And then simply multiplying 2 plus x minus 2 plus x times negative 1 rather, that gives us negative 2 minus x, and then multiplying negative 7 times 1, that's negative 7, and then multiplying negative times negative x, that's times 1, that's positive x. So combining them together, since these are both, we see two terms to be combined. So x minus x, that is 0, and then negative 7 minus 2, that's negative 9, all over 2 plus x squared. Since our 2 plus x is our v, then it will be squared. So now we have just obtained the derivative of 7 minus x all over 2 plus x, which is negative 9 all over 2 plus x squared. So that is how simply we have obtained the derivative or the differentiation of algebraic expression using formulas. So it is very important for us to calculate the derivative or to differentiate it because it applies to real life experiences, especially in terms of physics, engineering, and how things change. And by simply applying rather this formula, then we can obtain its derivative depending on what is asked from the given expression. So that would be all. Thank you so much for listening and for your watching. God bless.